Welcome to my Advanced Database Management System course. In this section, we discuss about partitioning and sharding, range partitioning, hash partitioning, benefits of partitioning, benefits of sharding. Let's enjoy. Partitioning and sharding are techniques used in distributed database systems to horizontally scale and distribute data across multiple servers or nodes. While both approaches aim to improve database performance and scalability, they have different implementations and use cases. Partitioning. Definition. Partitioning involves dividing a large database table or index into smaller, more manageable segments called partitions. Each partition contains a subset of the data and can be stored on a separate storage device, server, or node. Types of partitioning. Range partitioning. Data is partitioned based on a range of values in a specific column. Example, partitioning by date ranges. Hash partitioning. Data is partitioned based on a hash function applied to a specific column's values. This ensures uniform distribution of data across partitions. List partitioning. Data is partitioned based on predefined lists of values for a specific column. Composite partitioning combines multiple partitioning methods. Example, range and hash partitioning to partition data based on different criteria. Benefits of partitioning. Improved performance. Partitioning allows queries and data retrieval operations to be distributed across multiple partitions, reducing contention and improving query performance. Scalability. Adding new partitions enables horizontal scaling of the database, accommodating larger data volumes and increasing throughput. Manageability. Partitioning facilitates easier management of large datasets by dividing them into smaller, more manageable units. Sharding. Definition. Sharding, also known as horizontal partitioning, involves distributing data across multiple independent database instances or shards. Each shard is responsible for storing a subset of the data, and data distribution is typically based on a sharding key. Key value sharding. In key value sharding, each shard is responsible for a specific range of keys or values. This ensures that data with similar keys are stored together on the same shard. Benefits of sharding. Scalability. Sharding enables linear scalability by distributing data and query load across multiple shards. As data volume and query throughput increase, additional shards can be added to handle the load. Fault isolation. Each shard operates independently, providing fault isolation and resilience. A failure in one shard does not affect the availability of other shards. Geographical distribution. Sharding allows data to be distributed geographically across multiple data centers or regions, improving data locality and reducing latency for users in different locations. Comparison. Partitioning, primarily used in single database instances, divides data within a single database, offers improved performance and manageability for large datasets. Sharding, used in distributed database systems, distributes data across multiple independent database instances or shards, enables linear scalability and fault isolation for distributed applications. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.